In this video, we're going to go over number 4 and 5 from the Chapter 3 practice test. So here we have the number of students at a local high school have seen a viral video can be modeled by this function here. And so hopefully right away we recognize this as a logistic growth function. And one of the important things about logistic growth is that it shows a carrying capacity, which is the numerator. As t goes towards infinity, the outputs will approach this numerator. So the maximum number of students would be 1,850. And we just need to know that from knowing the nature of this function. Now you could certainly figure that out by plugging in huge values of t, but it's really just something you need to know about a logistic function here. Because the maximum for other functions does not occur as the end behavior, but in this case it does. How many students have seen the viral video after 10 days? Well, in this case, we're just going to plug in 10 for t. Be careful with your calculator. If you have an older version, make sure you put the entire denominator in parentheses to make sure that it's 1,850 divided by this whole thing. Also want to put the entire exponent in parentheses to make sure that it is e to the negative 0.3t as opposed to e to the negative 0.3 times t. If you have the newer calculator, it shows you nice boxes and where things are, so that's friendly. But if not, be careful. Add parentheses. So we plug in 10, and we get about 371 when rounded to the nearest whole number, as it says in this particular problem. On what day will this number of students reach half the maximum? Well, the maximum is 1850. So in this case, we're going to have to do a little bit of work, so I'm going to scroll this here. The maximum is 1850, so half of that is 925. And now I'm solving for t. If my output is 925, I now need to solve this expression for t. And there's a little bit of work to do here. First, I want to multiply this to the other side to get my t, my variable, out of the denominator. We'll kind of walk through it pretty slowly here, I think. A lot of steps. Don't want to rush it. And now I want to get rid of this 925, so I'm going to divide that over. Now I can sort of do a little more work. So then 1 plus 80 e to the negative 0.3t is equal to 2. And then move the 1 over, divide by the 80, and I have e to the negative 0.3t is equal to 1 over 80. And then because now my variable is inside this exponent, I now need to use a logarithm. Now, yes, the variable was inside the exponent the entire time, but I had to get rid of everything outside of that exponential function first. I had to get it out of the denominator, get rid of this 925, get rid of the 1, get rid of the 80. Now it's just an exponential function, so now I can finally use logarithms to actually solve this. So I'm just going to rewrite it in logarithmic form. It's log base e, which we call the natural log, of 1/80th equals negative 0.3t. Next step, just to divide by that negative 0.3. And if we do that, I believe we get about 14.607, which, again, the problem says to round to the nearest whole number, so that would be 15. So on what day? On the 15th day. Okay. Last question here is, does a logistic model make sense in this context? And again, what this context is the number of students who have seen a particular viral video. Now, as we said to start, one of the aspects of a logistic growth function is that it has that carrying capacity, it has that plateau, which of course makes sense. There are only so many students that attend the high school. So we would assume that 1850 is the number of students in the school. And so we're going to grow, but we can never grow past that. Now, the other thing about logistic growth is that it grows quickly to start. It looks exponential initially, and then it starts flattening out. So that is another good example of why logistic growth makes sense in this case, because sort of by definition of a viral video, we expect that the number of students who see it spreads really rapidly at first. You know, one person sees it, and then 2, and then 4, and then 8, and then 16, and then 32. It goes quickly. But then after we get to nearing the carrying capacity, well, that rate of growth has to slow down. So we want to hit both of those things in terms of our why does it make sense. Yes, fast initial growth. Yes, carrying capacity and leveling off eventually. All right, that is numbers 4 and 5.